Okay, guys, this is our review for the unit test on polynomials. So keep in mind, biggest unit of the year. We've already been quizzed twice on this unit. So if you look at this unit, what did we have in this unit? So we had a review 2.6, and then it looks like we had another review at 2.11, and now we're looking at a review at 2.15, okay? So you also have, so you got 3 reviews, okay? So there are 3 reviews to look at. There was also a quiz right here, and there was a quiz right here. So you've got 3 reviews, you've got 2 quizzes to look at for this particular unit, and that will get us all in gear. So let's take a look. Listing possible rational roots. So this is plus or minus. So in this case, I'm going to have plus or minus the factors of 8 divided by the factors of 3. So this is plus or minus 1, 2, 4, 8 over 1, 3. So the complete list, plus or minus 1, 2, 4, 8. That's every number divided by 1. Now each of those numbers divided by 3. And that is it. That's the complete list of possible roots for that polynomial. Factor completely and find all roots, capital letters and bold. That means complex and real. So you've got to know how to factor this. So to factor and find all roots, that means I need to be able to set it equal to 0. So x cubed plus 27 equals 0. You have to know how to factor the difference of cubes and the sum of cubes. This is the sum of 2 perfect cubes. So that's x squared minus 3x plus 9 equals 0. If you don't know how to factor this as the sum or difference of cubes, you're going to miss this. There's a formula you have to know for this. Okay, so go back and look at your notes. Now, if I set all of these equal to 0, so when x plus 3 is equal to 0, that gives me x equal negative 3. That is one of my roots. And then if I look at the other root is going to be x squared minus 3x plus 9 equals 0. This is quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So this is x equal 3 plus or minus, and that is what 9 minus 36, so the square root of 9 minus 36, all of this over 2, okay? And so the square root of 9 minus 26, so 36 minus, that's going to be what, 27? So this is x equal 3 plus or minus the square root of minus 27 over 2. So continuing over here, that is 3 plus or minus, so that's going to be I, and then I can write 27 as 9 times 3, all of that over 2. So this is 3 plus or minus 3 root 3 over 2, okay? So your roots are going to be what you see there. So you can write it just like that, 3 plus or minus 3i root 2, and keep in mind there's an I right there, 3i root, and it's not 2, it is 3 over 2, okay? And the complete factorization of this polynomial, the rational factorization is just x plus 3, x squared, what was it, minus 3x plus 9, okay? So I would be very explicit if I tell you that I want to see complex numbers in the factorization, okay? So this one I'm seeing rational numbers in the factorization. If I look at the next one that needs to be factored, I might try factor by grouping, but I can see with that 17 and 14, that's really not going to work for me. So I'm probably going to need to do synthetic division here. If I add the coefficients up, they do not add to 0. So it's going to be plus or minus the factors of 14 over 2, so that's plus or minus 1, 7, 2, and 14 over 1 and 2. Okay, so 1 doesn't work. Let's try negative 1. So negative 1, and let's work this with 2, 1, negative 17, 14. So I get negative 2, negative 1, and then I get 1, negative 16. Multiply here 16, that does not work. Okay, let's move on to 2. So let's try 2, 2, 1, negative 17, 14. You bring down the 2, 4 plus 1 is 5. Multiply, get 10 minus 7, 2 times negative 7, negative 14, that is 0. So that means that x equal 2 is a root. X minus 2 is a factor. So this polynomial is f of x equal x minus 2 times 2x squared plus 5x minus 7. Okay? 2x squared plus 5x minus 7. Are there numbers that multiply to give me a negative 14 and add to give me a 5? It looks like those numbers are going to be 7 and negative 2. So I can write this as 2x squared plus 7x minus 2x minus 7. Factor out an x, and you get 2x plus 7 minus 2x plus 7. This is x minus 1, 2x plus 7. Did I do that right? Oh, I missed something very quickly here. These coefficients, 2 plus 1 is 3. 3 plus 14 is 17 minus 71 would have worked. So I could have started with 1. Okay, I started with negative 1. So anyway, no harm done. I still get to the same answer. So the roots to this polynomial are going to be at 2 and at 1 and at negative 7 halves. Complete factorization is f of x equal x minus 2, x minus 1, and 2x plus 7. Write a polynomial of least degree with coefficients 2 and 1 plus root 2i. So this polynomial is f of x equal x minus 2 and x minus 1 plus square root of 2i. And then I must have x minus 1 plus. So x minus 1 plus square root of 2i. And then I must also have 1 minus square root of 2 times I. So I need to multiply. So this is going to give me what f of x equal x minus 2, x minus 1 minus, why don't we write it like this, I root 2, x minus 1 plus I root 2. So I don't get confused, that I is not under the square root sign. So I need to multiply x minus 1 minus I root 2 times x minus 1 plus I root 2. X times x, x squared, negative x, negative ix root 2, and then negative x, positive 1, and then plus I root 2, and then xi root 2, negative I root 2, and then this last one, don't mess this one up, this is I root 2 times minus I root 2. Root 2 times root 2 is 2. I times negative I is negative I squared. But I squared is negative 1. So this answer is simply 2. So this gives me f of x equal x minus 2 times x squared. Now what happened over here was negative ix root 2, ix root 2, negative I root 2, I root 2. So this gives me x minus 2, x squared minus 2x plus 3. Now I just need to multiply all of that together. So x minus 2, x squared minus 2x plus 3. This gives me x cubed minus 2x squared minus 2x squared plus 4x plus 3x minus 6. Final answer, f of x equal x cubed minus 4x squared plus 7x minus 6. Okay, and I can double check that. Let me double check it before I go on. And that answer is correct. I just double checked to make sure I didn't make any arithmetic mistakes. Consider this polynomial, okay? If I look at this polynomial, what is the degree of this polynomial? So it looks like I've got, what, 4 roots? I've got 3 turns in the graph. So this has to be a 4th degree even polynomial, okay? Leading coefficient needs to be positive there because both ends are going up. Describe this in limit notation. So the limit as x approaches negative infinity of f of x, that approaches infinity. The limit as x approaches infinity of f of x also approaches infinity. What are the x-intercepts? Those are negative 4, 0, negative 2, 0, 1, 0, and 4, 0. What's the y-intercept? That is 0, 1. Write the equation of this exact polynomial, okay? So this polynomial is f of x equals some coefficient, I'm not sure what, but then it has to be x plus 4, x plus 2, x minus 1, x minus 4. I know that when I substitute a 0 in, I better get a 1 as my answer. So 1 has to equal a times 4 times 2 negative 1 times negative 4. So this becomes 1 is equal to, what, 8 times 4, that's 32, 32a. So a is equal to 1 over 32. So this final answer is f of x equal 1 over 32. And then it's just all of those factors. X plus 4, x plus 2, x minus 1, x minus 4. Okay? And no need to multiply all of that out. Looking at this polynomial, I give you it in standard form and I give you in factored form. This is a 5th degree polynomial. Leading coefficient is 1. So if it's a 5th degree and a leading coefficient of 1, it has to go down on the left and up on the right. So the answer to these limits is negative infinity, positive infinity. What are the x-intercepts? Negative 1, 0, 2, 0, negative 3, 0, and 3, 0. What is the y-intercept? When you let x equal 0, the easiest place to do that is right here. When x is 0, that answer is negative 36. So 0, negative 36. You can get the same answer by plugging into here, but it's just more work, okay? If I plugged in a 0 there, I would get 1 times negative 2 squared times 3 times negative 3, and I would hope not to make arithmetic mistakes. This is, what, 4 times negative 9, which is negative 36. So I get to the same number. There is a multiplicity of 2 at x equal 2. So when I go to graph this, I know that at the point 2, I do not cross the axis. All the other routes, I will cross the axis. So I'm going to cross at negative 1, I'm going to cross at negative 3, and at positive 3. And I have to go through the point 0, negative 36. So it doesn't really matter to me, but just mark that down here somewhere, 0, negative 36. And then this graph has to start from the bottom, so it needs to go up, and can it do all of those things? So can it go up, hit the y-intercept, do not cross, cross one more time, and keep going on your way up. So that is the graph of this particular polynomial. Looking at this polynomial, is this even or odd degree? This has to be an even degree polynomial. It goes up on both ends. Leading coefficient has to be positive. Absolute minimum is this point here, what, negative 0.69, negative 8.1, negative 0.69, negative 8.1. Okay, is there an absolute maximum of this point? There is no absolute maximum of this point. So any other max or min has to be relative. So it looks like there's going to be a relative minimum at 2, 0, and a relative maximum at 1.53, 16.2. Intervals of increase. So as I travel from left to right, I increase from negative 0.69 until I get to 1.53. So that is an interval of increase. The next interval of increase is going to be from 2 to infinity. Intervals of decrease. I decrease from negative infinity to negative 0.69. The next place that I decrease is from 1.53 to 2. Perform the indicated operation. So here I'm just multiplying two polynomials together. So the way we did this best was, let's create a chart, and then x squared minus 4x plus 4. So I get 2x cubed minus 8x squared plus 8x. I get 3x squared minus 12x plus 12. So this polynomial, I don't really need to do that. This operation yields what? 2x cubed minus 5x squared. 12 minus 8, that's minus 4x plus 12. 2x plus 1 cubed, okay? We have a formula, a plus b cubed is a cubed plus 3a squared b plus 3a b squared plus b cubed. That's one way of doing this. That would give me, so you get 8x cubed plus 3. You square that times 1 plus 3, 2x times 1 squared plus 1. This is 8x cubed plus 12x squared. So plus 12x squared plus 6x plus 1. Now, if you're saying I'm just not going to remember that formula, the other way to do this is 2x plus 1 times 2x plus 1 times 2x plus 1. So this is 2x plus 1 times 4x squared plus 4x plus 1. Now I just go back to what I did a moment ago, where I've got 4x squared, 4x and 1, 2x and 1, and I make a table to show me all of that. So I get 8x cubed, 8x squared, 2x, and then I get 4x squared, and then I get 4x plus 1. This should give me the same exact answer of what I saw right here. So 8x cubed plus 12x squared plus 6x plus 1. Same answer. Use long division to complete the following. Okay, so I'm dividing x minus 2 into 2x cubed minus 3x squared minus 8. So what do you multiply x by to get 2x cubed? That's 2x squared. So when I do that, I get 2x cubed, and then I get minus 4x squared. Subtract all of that, and that gives you x squared minus 8. What do you multiply x by to get x squared? That is an x. So that gives me x squared, and then I get minus 2x, okay? So in this case, what I'm left with when I do the subtraction here, I'm left with, what am I left with? I'm left with 2x minus 8, okay? What do you multiply x by to get 2x? That's a 2. So that gives me 2x minus 4. Subtract all of that, and I get negative 4. So this answer is 2x squared plus x plus 2 minus 4 over x minus 2. Next problem, consider this polynomial. Which of the choices could possibly be the list of all roots of this polynomial? So I can see automatically, I see a root at negative 2. So this first one does not have a negative 2 in it. It cannot be that one. All the others have a negative 2, okay? This thing has multiple terms. I see 1, 2, 3 terms, so it's got to be at least a 4th degree polynomial, okay? So it's got more roots. They're complex. It cannot be this one because I've got different roots that are complex in this particular one. So now it just boils down to which of B or C. Now what you can see here, the difference is if this has the square root of 2i as a root, well, in order to have real coefficients in this polynomial, to be able to graph this, I've got to have the conjugate of that root as well. So it has to be choice C. That is the only thing I can have in this case, okay? So it does have more than the one root because it has more turns in the graph. So it cannot be as simple as D. It cannot be A because I don't have a root over here at 2. So it's either B or C, and it's the conjugate theory that helps me narrow down that particular one. Graph and write a possible equation for a 6th degree polynomial that has an absolute maximum at the point shown, and it has zeros at plus or minus 3, plus or minus 1. It only crosses at 3 and 1. So let's draw what we see. 1, 2, 3. 1, 2, 3. It only crosses at x equal 3 and at x equal negative 1. So that means it does not cross at negative 3 and it does not cross at positive 1. Okay? So if this is a 6th degree polynomial with an absolute maximum, it's going to have to start down here and end down here. So my choices are, can it do that? Can it go up here and then go through this point, has an absolute maximum, bounce here and come back down? Yes, that is all within the realm of possibility. And so if I look at this polynomial, so that's the graph. What is the equation? F of x is going to be equal. So a possible equation, this has to be, this is what, negative 3, negative 1, 1, and 3. So I have to have a multiplicity at negative 3. So that's going to have to be x plus 3 squared. X plus 1, I crossed, no multiplicity. X minus 1, I did not cross, so I get multiplicity. X minus 3. What's the degree of this guy? This is what, 1, 2, 3, 4, 5, 6. This is 6th degree. That's what I wanted it to be. But what about the leading coefficient? If this thing is graphed just like you see, it has to have a negative leading coefficient. So this has to be the equation for this potential graph. So that is it, guys. There's a lot of material on this particular quiz. This is a review, but don't forget when we started out for this particular review, it's not just this review. There were reviews that you saw leading up to this, so the 2 quizzes and the 2 previous reviews.